Hello and welcome to Ascent Gate Academy. Our next chapter is probability. Now before starting probability, we will learn some of the basic concepts of permutation and combination. Now we will start the permutation combination with fundamental principle of counting. Now in fundamental principle of counting, basically we have two different rules. The first rule is multiplication rule and the second rule is addition rule. Now this multiplication rule says that if a work A can be done in m different ways and work B can be done in n different ways, and C is a work which is completed when both A and B are completed. Okay, so this is the statement of multiplication rule. There is a work which is completed in two steps. The first step is A and the second step is B. The first step can be done in m different ways and the second step can be done in n different ways. Now the multiplication rule says that if the work C is completed when both A and B are completed, then number of ways of doing this work C, this will be simply m into n. So let me give you one very basic example. Suppose if there are 3 points A, B and C, and our job is we have to go from point A to C, but the first step is I have to go from A to B and the second step is I have to go from B to C. Now suppose there are two paths connecting point A and B. There are two ways to go from point A to B. Either you can go along path 1 or path 2. And say there are three ways to go from point B to C. Say these are the three paths connecting point B and C. These are the three paths A, B, C. Now here if I ask you how many ways are there to go from point A to C. So the first part of the job can be done in two different ways. The second part of the job can be done in three different ways. So the number of ways of doing this work, this will be simply 2 into 3, 6. So this is a very basic example of multiplication rule, that if a work is done in number of steps, then number of ways of doing the total work, that will be the product of individual number of steps. You can take another example. Suppose if I have 4 points, say I have the point A, B, C and D, and I have to go from point A to D, but the first step is I have to go from A to B. Now say there are two ways to go from A to B. Then second step is I have to go from B to C, and there are three ways to go from point B to C. And similarly say there are 4 ways to go from point C to D. Now here in this case, if I ask you how many ways are there to go from point A to D, so A to B, this is the first step, this can be done in two different ways. B to C, second step, this can be done in 3 different ways. And C to D, this is third step, and this can be done in 4 different ways. So here the number of ways of doing this total work which is going from point A to B, this can be done in 2 into 3 into 4, that is 12, that is 24 ways. So you have to apply this multiplication rule when the work is completed in number of steps and the total work is completed when each of the individual steps is completed. So this was first rule, multiplication rule. The second one is addition rule. Okay, the next one is addition rule. Now the statement of this addition rule is similar to multiplication rule. The statement is that if a work A can be done in m different ways and work B can be done in m different ways, and C is a work which is completed when either A or B is completed. Now notice the difference here. In case of multiplication rule, the work C was completed when both A and B is completed. Now here in addition rule, the work C is completed when either A or B is completed. Then in this case the number of ways of doing this work C, this will be simply m plus n. So again let me give you an example. Suppose if I have a room and say there are 2 gates on left side, these are the 2 gates 1 and 2, and say there are 3 gates on right side, say these are the 3 gates 1, 2, 3. Now here if I ask you how many ways are there to enter inside the room, so you can enter either from the left side or from the right side. There are 2 ways to enter from left side, 3 ways to enter from right side. So here the number of ways of doing this work, this will be simply 2 plus 3, 5. Now here we have applied the addition rule because the work is completed in only one step. Either you can enter from left side or from right side. So when a work is completed in number of steps, then you have to apply the multiplication rule. And if the work is completed in only one step, then you have to apply this addition rule. Now we are going to see some of the basic problem, and with the help of which we will see when to apply this addition rule and when to apply the multiplication rule. So our next problem is number of 4-digit numbers that can be formed using these 5 digits. Now notice this problem is similar to the one that we have already solved, except that I have one more digit 0 here. Okay, these two are same. First part when repetition is not allowed, second part when the digits can be repeated any number of times. Now again 4-digit number means we have to fill these 4 places using the given 5 digits. But now we have a problem. The problem is that we have this 0 here and we cannot place 0 on 1000 place. Okay, if you place 0 on 1000 place, then in that case the number will be of 3 digit. The question is we have to form 4-digit number. So this means we cannot place 0 on 1000 place. So we have to start with the 1000 place. In the earlier example we started with unit place, but we could have started from any other place also and we would have obtained the same answer. But here, since there is restriction on 1000 place, we cannot place 0 on 1000 place. So we are going to start with this 1000 place. So how many ways are there to fill this 1000 place? So you can see that there are 4 non-zero digits, 1, 2, 3, 4, and you can place any one of these 4 digits on 1000 place. So this means there are 4 ways to fill the 1000 place. Either you can place 1 or 2 or 3 or 4. Now since the repetition is not allowed, for the next place, total 5 digits are there. One of the digit is at 1000 place. So for the next place we will have 4 options. Okay, 5 minus 1, 1 is on 1000 place. So for the next place we will have 4 options, because one non-zero is here, but on 100 place we can place 0 here. So there are 4 ways to fill this 100 place. Then for 10th place, total 5 digits are there. 2 are at 100 and 1000 place. So for the next place we will have 3 options, and for unit place we will have 2 different options. So in this case the number of 4-digit numbers, that will be 4 into 4 into 3 into 2. So this will be 24 into 4, 96. So when 0 is there and repetition is not allowed, then total 96 numbers are possible using these 5 digits. And the second part of the problem is when the digits can be repeated any number of times. So now again we have to fill these 4 places using the given 5 digits. And since we have 0 here, so we have to place non-zero digit at 1000 place. So there are 4 ways to fill this 1000 place. We can place any one of these 4 non-zero digits on 1000 place. Then for 100 place we will have 5 different options. Since repetition is allowed, any digits can be repeated any number of times. So there are 5 options for 100 place. Similarly 5 options for 10th place and 5 options for unit place. So when the repetition is allowed, then in that case the number of 5-digit number will be 4 into 5 into 5 into 5. So this will be 125 into 4, that is 500. So when repetition is not allowed, then 96 numbers are possible. When repetition is allowed, then 500 numbers are possible. Okay, so our next problem is find the number of 5-digit even numbers that can be formed using the digits 1, 2, 3, 4, 5 when repetition is not allowed. So here we have to form even number. Now we know that a number is even number when the digit on unit place is even. So first of all we have to form 5-digit number. So this means we have to form 5 box. So say these are the 5 box. Now since we have to form even number, so therefore we have to start from the unit place. See, in earlier example we started with 1000 place because the reason was we cannot place 0 on 1000 place. We had to place any non-zero digit on 1000 place. Now here the problem is we have to form even number, so this means we have to start from unit place. Now the restriction is on unit place, we have to place even digit on unit place. So now you can easily see that there are 2 even digits, 2 and 4. So this means there will be 2 ways to fill this unit place. Either you can place 2 or you can place 4 on this unit place. And the remaining box you can fill in any order. So since the repetition is not allowed and one of the digit is at unit place, so number of ways to fill the 10th place, this will be 4, then 3, 2 and 1. So number of 5-digit even numbers that can be formed using these 5 digits, this will be simply 1 into 2 into 3 into 4 into 2. So this will be 48. Now this was a very simple problem. Next I am going to solve. Okay, so this was very basic problem. Now next we are going to see another variation of the similar problem. So our next question will be find the number of 5-digit even numbers that can be formed using the digits. And okay, so our next problem is, and this is a very interesting problem. The question is find the number of 4-digit even numbers that can be formed using the digits 0, 1, 2, 3, 4, 5. Now see, here we have to form even number and 0 is also there. So first let me explain what is the approach of the student, and then we'll see what should be the correct approach. So the question is find the number of 4-digit even number. So this means we have to form we have to fill these 4 places. Now even number means we have to place even digit on unit place. Now the even digits are 0, 2 and 4. These are the 3 even digits. So suppose if I am writing 3 here, 3 will mean that I am placing 0 here or 2 or 4. So now since the number has to be of 4 digits, so this means on 1000 place we have to place any non-zero digits. So if I ask you how many ways are there to fill this 1000 place, so that will depend on what digit we have placed on unit place, right? If I have placed 0 on unit place, so this means in that case for 1000 place we will have 5 different options. I can place any one of these 5 digits on 1000 place. But if you have placed 2 or 4 on unit place, so in that case you will have only 4 options, because 0 you cannot place on 1000 place. One of the non-zero digit, either 2 or 4, is at unit place. Suppose if you are placing 2 on this unit place, so this means for 1000 place you cannot place 0, 2 is at unit place. So this means for 1000 place you will have only these 4 options, either 1, 3, 4 or 5. So the number of ways to fill this 1000 place, that will depend on what digit you are placing on unit place. If you are placing 0, then you will have 5 options. If you are placing 2 or 4, then you will have 4 different options. So for these type of problem we have to consider 2 different cases. Here you cannot write 3, because the moment you write 3, we don't know what we should write on 1000 place. The number of ways to fill this 1000 place, this will change depending on whether you have placed 0 or non-zero here. So for these type of problem we have to consider 2 different cases. Okay. So the first case will be case 1, when 0 is at unit place. 0 is at unit place. So when 0 is at unit place, then in that case, since we have to form 4 digit number, this means we have to fill these 4 places. And since 0 is at unit place, so this means there is only one way to fill this unit place. We have to place 0 here. Now number of ways to fill this 1000 place, this will be 5, because you can place any one of the remaining 5 non-zero digit on 1000 place. And similarly, number of ways to fill this 100 place, total 6 digits are there, 1 at unit, 1 at 1000. So number of ways to fill this 100 place, this will be 4, because you can place any one of the remaining 4 digit on 100 place. And the number of ways to fill the 10th place, this will be 3. So when 0 is at unit place, when 0 is at unit place, then in that case the number of even numbers will be 5 into 4 into 3 into 1. Now if you multiply all these numbers, you will get 20 into 3, 60. So 60 even numbers are possible which will have 0 at unit place. Then second case is case 2, when 2 or 4 is at unit place. Now when 2 or 4 is at unit place, again we have to fill these 4 places. When 2 or 4 is at unit place, then in that case there are 2 ways to fill the unit place. Either you can place 2 here or you can place 4 here. So there are 2 ways to fill the unit place, and now we have to fill this 1000 place. So the number of ways to fill this 1000 place will be, you cannot place 0 here, one non-zero digit is already at unit place. So this means number of ways to fill this 1000 place, this will be 4. Okay, 0 you can't place, one of the non-zero digits is at unit place. So out of these 5 non-zero digits, only 4 are there for this 1000 place. So number of ways to fill this 1000 place, this will be 4. Then for the 100 place, again we had total digit is 6. 2 digits are at unit and 1000 place. So number of ways to fill this 100 place, this will be 4. And for 10th place, you will have 3 options. So in this case, the number of even numbers will be 4 into 4 into 3 into 2. Now if you multiply all this, then you will get 96. So 60 even numbers are possible which will have 0 at unit place. 96 even numbers are possible which will have 2 or 4 at unit place. So the number of even numbers will be 60 plus 96. So this will be 156. Notice that here we had applied the addition rule, because here the work is complete. Either you can form even number in this manner or in this second case. So number of even numbers will be 60 plus 96, which is 156. So this was a very good problem. Okay, now our next problem is find the number of 4-digit numbers divisible by 4 that can be formed using the digits 1, 2, 3, 4, 5, when repetition is not allowed. So we have to form 4-digit number which are divisible by 5. Now the condition for divisible by 4. So the condition for divisibility by 4 is that the last 2 digits should be divisible by 4. Okay, for example, suppose if I have a number say 4, 6, 7, 1, 2. Now if I want to find whether this number is divisible by 4 or not, then you have to see only the last 2 digit. If the last 2 digit is divisible by 4, then in that case this number will be divisible by 4. So here our problem is we have to form, now obviously this number will be divisible by 4 because 12 is divisible by 4. Now our problem is we have to form 4-digit numbers divisible by 4 that can be formed using these 5 digits. So since we have to form 4-digit number, we have to fill these 4 places. But now we have to fill the last 2 places simultaneously. The reason is I have to place only those pair of number in the last 2 places which are divisible by 4. So we are going to see what are the possible option for the last 2 place. So if I have 1 on 10th place, then I can place 2 on unit place. So one possibility is 1, 2. I can place 1, 2 on these last 2 places, and in that case the number will be divisible by 4. So one possibility is 1, 2. Another possibility will be 2, 4. See, you don't have to write these combinations randomly. You have to proceed in a sequential manner. If I have 1 on 10th place, then I can place 2 on unit place. If I have 2 on 10th place, then I can place 4 on unit place. Similarly 3, 2. Okay. Then if I have 4 on 10th, then I should have 4 on unit place. But since repetition is not allowed, I cannot place 4, 4. So nothing with 4. Then next, if I have 5 on 10th place, then I can place 2 on unit place. So these are the 4 possibility for the last 2 places. Either you can place 1, 2 here, or 2, 4, or 3, 2, or 5, 2. So the number of ways to fill the last 2 places, this will be 4. Okay, there are 4 ways to fill the unit place and 10th place simultaneously, in which the number will be divisible by 4. Now the number of ways to fill this 100th place, total 5 digits are there, 2 digit is at unit and 10th place. So this means remaining number of digit is 3. So number of ways to fill the 100th place, this will be 3, and the number of ways to fill the 1000th place, this will be 2. So here the number of 4-digit numbers divisible by 4, this will be simply 2 into 3 into 4, which is 24. Okay, so this was a very basic problem. Only thing is that you have to see that you have to fill the last 2 places simultaneously. Only in that case the number will be divisible by 4. So these were some of the basic problem based on the fundamental principle of counting. Now next we are going to see permutation, and then we will talk about combination. Okay, so our next topic is permutation. Now the meaning of this word permutation is arrangement. Permutation simply means arrangement, and the first theorem is the number of permutation of n different object. Now this word different is very important. We can apply this theorem only when all the objects are distinct or different. So the number of permutation of n different things taken r at a time is given by, now the formula is npr. This will be the number of ways to arrange r out of n object. So this npr will be simply factorial n, this divided by factorial n minus r. Now with the help of one example, we will see how to apply this formula. So for example, suppose if the question is find a number of 4-lettered word, find a number of 4-lettered word that can be formed using the letters of word, machine. So this is the problem that we have. The question is we have to form 4-lettered word, and we have to use the letters of this word machine. Now the question is, word formation is an example of permutation. Okay, here we have to arrange 4 out of these 7 letters. So total 7 letters are there. So this means n is 7, M-A-C-H-I-N-E. So total 7 letters are there. So this means n is 7. Now the question is we have to form 4-lettered word. So this means in place of r you have 4. N is 7, r is 4. So the number of 4-lettered word, this will be simply 7p4. Now 7p4 you can write as factorial 7 by factorial 7 minus 4. So this will be factorial 7 by factorial 3. Now factorial 7 you can write as 7 into 6 into 5 into 4 into 3 factorial, and this divided by 3 factorial. Now if you do the calculation, this will be 42 into 20, so this will be 840. So this means total 840 words are possible, which are of 4 lettered, and which can be and the letters that are used are from the letters of word machine. Now see, here we can apply this formula NPR because all these 7 letters are distinct. Okay, if there is some repetition here, then you cannot apply this formula. So therefore this theorem is to be applied only when all the n objects are distinct. Now this was first theorem. The second one is the number of permutation of n different objects taken n at a time. Okay, this is second theorem. So number of permutation of n distinct objects taken n at a time. This is given by npn, and this npn will be nothing but factorial n by factorial n minus n. Now factorial n minus n will be factorial 0. Factorial 0 is 1, so this will be factorial n. So number of ways to arrange n object on n places, this will be simply factorial n. See, the value of factorial 0 is defined as 1 only to make this formula NPR valid when r is equal to n. We have seen that the formula for NPR is factorial n by factorial n minus r. Now when r is equal to n, then in that case we know that NPN will be simply factorial n. So only to make this formula valid when r is equal to n, factorial 0 is defined as 1. So these are the two basic theorems that you have to remember. NPR will be factorial n by factorial n minus r. NPN will be factorial n. This formula you have to apply only when all the n objects are different. Now we are going to see some of the special cases in permutation. So our next heading will be permutation under different conditions. Okay, so our next topic is permutation under different conditions. Now under this topic we will see different type of cases. So the first case is when all objects are not distinct. See, the formula for NPR that we had seen was factorial n by factorial n minus r, and the formula for NPN, this was factorial n. But these two formula you had to apply only when all the n objects are different. Now here we will see what happens when some of the objects are same. So I will explain that concept with the help of one example. Suppose if I have this word APPLE, and here if I ask you how many 5-lettered words are possible using these 5 letters. So here you cannot apply this formula NPN. The reason is that all the n objects are not different. You have two identical P. Now for a moment consider that these two letters are different. One letter is P1 and another letter is P2. Now in this case if I ask you how many 5 letters are possible. So now we have 5 letters and all the 5 letters are different. One is P1, other is P2. So in that case the number of 5-lettered word, this will be factorial 5, right? Factorial 5, this will mean simply 120. So now what are those 120 words? First word is A P1 P2 LE. The second word will be A P2 P1 LE. The third word you can think of is ALE P1 P2. Another possible word is ALE P2 P1, and in this way you can form total 120 word. Now see, P1 P2 are not different. Okay, so this means these two words are same. The first word is APPLE, the second word is also same, APPLE. So these two words are same. Similarly, these two words again are same, ALE P1 P2 and ALE P2 P1. So total 120 words are there, out of which these two are same, these two are again same. So this means the number of different words, this will be simply factorial 5 by 2. Or you can write this as factorial 2. Okay. So when some letters are repeated, then you have to divide by the factorial of that number. So here the number of different words, this will be simply factorial 5 by factorial 2. Now you can think of another example, okay, to understand the concept of this meaning factorial. Suppose if I have a word, say DADDY. Now here if I ask you how many 5-lettered words are possible, and say if one is D1, other is D2 and another one is D3. So in this case the number of different words that is possible is again factorial 5. We have 5-lettered and all the 5 letters are different. Now factorial 5, this will mean 120, so total 120 words are possible. Now what are those words? One word is D1A, D2, D3Y. Another word you can think of is D1A, D3 D2y, similarly D2a, D1 D3y, D2a, D3 D1y, D3a, D1 D2y, and finally D3a, D2 D1y. So in this way total 120 words you can form. Now if you see carefully, these 6 words are same. All the words are DA, So total 120 words were possible, out of which these factorial 3 number of words are same. Another factorial 3 number of words are same. So this means the number of different words, this will be simply factorial 5 by factorial 3. Okay, so this was very basic example. When all the objects are not distinct, then you have to divide by the factorial of number of times any particular letter is repeated. Another example that you can think of is, and this is a very popular example, this chapter is incomplete without this example. So suppose if I have this word, say Mississippi, and if I ask you how many 11 letters word are possible using these 11 letters, okay, you can easily see that there are total 11 letters. So if I ask you number of 11 lettered word that can be formed using the letters of word Mississippi, so this will be factorial 11, this divided by, now you can see that there are 4 identical S. Okay, you have 2S here and 2S here, so you have 4 identical S, then 4 identical I, 2P and 1M. Okay, these are the 11 letters that you have. So number of 11 lettered word, this will be simply factorial 11, this divided by factorial 4, then 4 identical I, so factorial 4, 2 identical P, so again factorial 2. So this will be the number of 11 lettered word that can be formed using the letters of word Mississippi. So whenever one or more letter is repeated, then in that case you have to apply this approach. Now, so this was first type. Next we are going to see some other cases. Okay, so next type is when certain types of objects are together. So I will explain this with the help of this example. The question is, find the number of ways to arrange the letters of word daughter such that all the vowels are together. Now see, there are total 8 letters. You have 3 vowels A, U, E, and then you have 5 consonant D, Z, H, T, R. So these are the 5 consonant and these are the 3 vowels. Now the question is, we have to arrange these 8 letters in such a way that all the 3 vowels are together. So for these type of problem, you have to count these 3 vowels as one single unit. Okay, so you have to count these 3 vowels as one, and then you have 5 unit of these 5 consonant. Now number of ways to arrange these 6 letters, okay, 5 consonant plus 1 unit of these 3 vowels, this will be factorial 6. Okay, and in all these arrangements you can also arrange these 3 vowels in factorial 3 ways. So this means the number of ways to arrange this will be simply factorial 6 into factorial 3. Now let me explain this thing further. Suppose if one word is, say, D, Z, H, T, R, and then you have A, U, E. Another possibility that you can think of is, say, D, G, T, H, R, then again A, U, E. So in this way, by taking these 3, by counting these 3 as one, total number of ways to arrange these 6 units, maybe you can think of as, say, A, U, E, D, Z, H, T, R. So in this way, total factorial 6 number of words you can form. These 3 as 1, and then you have these 5 units. So total number of ways to arrange these 6 units, this will be factorial 6. And from each one of these words, you can form 6 another word, right? By interchanging these words, you have D, G, H, T, R, and then you can interchange, say, U and E. So you can write A, U, E. So this will be one word. So in this way, from one word you can form 6 another word by interchanging these 3 letters. So from each one of these factorial 6 number of words, you can form factorial 3 number of words from each one of these words. So the total number of different word will be factorial 6 into factorial 3. Now suppose if the problem was, say, this was the first part of the problem. The second part of the problem is all consonant together. We have to arrange these 8 letters in such a manner that all consonants are together. So now you have 3 vowels A, U, E, and then you have 5 consonants D, Z, H, T, R. And now our problem is we have to arrange in such a manner that all the 5 consonants are together. So this means we have to count these 5 consonant as 1 unit. So you have 1 unit of these 5 consonant and then 3 unit of these 3 vowels. So the number of ways to arrange these 4 units will be factorial 4, and in each one of these arrangements you can also arrange these 5 consonant in factorial 5 ways. So this will be the number of ways to arrange these 8 letters such that all the consonants are together. So this was again a very basic example. Now our next type is the third one,